Welcome back, geometry. Let's take a look at example 2. So we already did example 1, which is how we figured out how we can prove quadrilaterals are parallelograms on a coordinate plane. So now let's take a look at number 1, which says prove quadrilateral cake is a parallelogram. So we want to do the same thing. We want to make sure that the opposite sides of this quadrilateral have parallel slopes. So we want to see if they have the same slope. So I'm just going to go ahead and get started. So let's find the slope of CA. So remember, the letter M stands for slope. So I need to find my change in Y and my change in X. So let's see. My change in Y is going to be 1, 2, 3. So I went up 3. Change in Y equals 3. And my change in X is going to be 1, 2, 3, and 4. My change in X is going to be 4. So the slope of segment CA is 3 over 4. Okay, now let's check the slope of EK. So the slope of EK. Okay, let's do the same thing, going from E to K. So let's see. My change in Y is going to be 1, 2, 3. I went up 3 and 1, 2, 3, 4. That means my change in X is going to be 4. So the slope of EK is going to be 3 over 4. Okay, so far so good. I now need to check the slopes of the other side. So I'm going to erase this to make room for the work that I'm going to do. Okay, now let's find the slope of AK. So M of AK. So going from A to K. All right, so going from A to K, I see that I'm going down, and I can just go ahead and count the number of spaces. So 1, 2, 3, 4. So my change in Y is -4, and 1, 2, 3, my change in X is going to be 3. So the slope of AK is -4 over 3. Okay, now let's find the slope of CE. So M of CE, and my change in Y is 1, 2, 3, 4, so -4. My change in X is going to be 3. So the slope of CE is -4 over 3. I'm going to go ahead and erase this work because in a moment we're going to do some more sketching on here. All right, so we've proved that the quadrilateral is a parallelogram, so I'm just going to go ahead and make a note of that over here. So I'm just going to shorthand, quadrilateral cake is a parallel, and I'm going to shorthand parallelogram, and I'm just using the symbol for parallel, which is like 2 L's. Quadrilateral cake is a parallelogram because opposite sides are parallel. And I'm just using the symbol for parallel right there. Okay, let's take a look at number 2. What do we notice about the slopes of the consecutive sides? So consecutive means right next to. So let's take a look at the slopes of CA and AK. So here is CA and here is AK. Well, I'm noticing that one is positive and one is negative, and the fractions are flipped. So that means that these are opposite reciprocal slopes. So the slopes are opposite reciprocals. Okay, what is the most specific name for this quadrilateral? So now I know. Now, not only do I know that it's a parallelogram, but it is a specific kind of parallelogram that has right angles. Because remember, if I've got slopes that are opposite reciprocals, they are perpendicular to each other. So these are all perpendicular segments to one another, which means they create 90-degree angles. And there are 2 shapes that create 90-degree angles. So it could either be a rectangle or it can be a square. Okay. Now, in order for it to be one or the other, we need to prove it. Okay, so just looking at the diagram, it looks like it's going to be a square, but I also need to show math to show that it is going to be a square. So in order to do that, we need to show that the distances of CA, AK, and KE are also all the same, because in a square, all of these sides should be congruent to each other. So let's go ahead and find the distance. So to find distance, we're going to use the Pythagorean theorem. Now, if you guys remember, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so that's not really anything new. So, and to use the Pythagorean theorem, I also need to use right triangles, which is nice because I've already created right triangles in my diagram. So for example, let's take a look at the right triangle that I've just drawn. I'm going to use this right triangle and I'm going to label this part A, this part B, and this part C because that's going to help me find the distance of CA. Well, A would be 3 and B would be 4. I'm really just counting the horizontal and the vertical distance. So let's go ahead and plug that into our formula. So I have 3 squared plus 4 squared equals C squared. That's what I'm trying to find. 3 squared is 9. 4 squared is 16. Now I can add those two numbers together. So I get 25 equals c squared. I'm going to take the square root of both sides, and I end up with 5. So that means that CA, the length of CA, is 5 units long. I want you guys to pay special close attention because this is something unique that happens when we use the Pythagorean theorem and the numbers work out nicely. This is called a Pythagorean triple. Now, Pythagorean triples are, like I said, when you substitute A and B and C into the Pythagorean theorem and you end up with nice whole numbers. 3, 4, 5 is one Pythagorean triple that you will see over and over in our class, okay? The 3 and the 4 have to be the legs. The 5, or the largest number, will always be the hypotenuse. So let's go ahead and check all of the other sides in this square. Let's find the length of AK. So now I'm going to focus in on this right triangle. Okay, and I've got a 90-degree angle right here. Okay, let's count our distances one more time. So this is going to be a distance of 3. This is going to be a distance of 4. And it looks like I've got another Pythagorean triple. This is going to be a 3, 4, 5 right triangle. So that tells me that the length of AK is also 5. Okay, let's go ahead and check everywhere else on this triangle. I next need to check EK, the length of segment EK. Okay, let's check that again. So let's see, this distance is going to be 3. This distance is going to be 4. So I've got a nice Pythagorean triple of 3, 4, which means this side is going to be 5. So EK is equal to 5. Okay, and last but not least, let's check this side over here. So I'm going to create this right triangle orientated this way. Here's my right angle. This distance is going to be 3. This distance is going to be 4, and I can count that. 1, 2, 3, 4, and then on the other side, 1, 2, 3. So I've got a 3, 4, which means CE is going to be 5. Okay, so now not only do I know that this shape has all right angles, but I know that all the sides are congruent, which means that this is not a rectangle, this is a square. That's the most specific name for this quadrilateral. Thanks for watching. Let's go ahead and try example 3.